Welcome back. So you should have just completed the general overview. If you haven't, I suggest you go back and do that now. So assuming you have, let's get started on the technical segment. So you may recall this graphic from the Rome conference. It's a very general application guideline, but it really covers the majority of the considerations a customer needs to make when selecting a gasket and a gasket material. So normally, the material type is specified by the end user, but you can use this chart to help your customer and potentially troubleshoot some of their guidelines and help make recommendations. So ultimately, it's a combination of all the characteristics on this chart and some of your end user specific process and quality requirements and even their risk assessment that's going to drive what gasket material they select. So for example, if you look at PTFE, right, as you know, PTFE is one of the most pure and one of the most chemical resistant materials that's out there on the market for gaskets. However, they do not seal as easily as rubber compounds. So if ease of installation and sealability is critical to your customer, then a PTFE gasket might not be the ultimate choice. That being said, there are customers that successfully use PTFE gaskets, and in those applications, it might be that chemical resistance and purity are most critical to them. So you can find this chart in the general Biopure brochure. I'm not going to walk point by point through every box on this chart, so I suggest you go to the brochure and review. But again, if you do have any questions, contact me. What I am going to do is do some specific success stories and how they relate to some extent with this chart. So I'm going to start with silicone. Right? You all know that silicone is one of the most pure rubber compounds, and it's typically the material of choice in single-use applications. And in those applications is typically where you're not seeing repeated SIP, you're not seeing harsh chemical environments, so that's why silicone is normally used in single-use applications. So here's an overview of our new silicone offering. Okay? All of it is liquid injection molded in an ISO Class 7 clean room. Recall in 2017, in this top box, we had laser etched parts along with a comprehensive validation pack that included things like BPOG type extractables. The market feedback indicated that we overshot on some of these specifications. The customers weren't willing to pay for or didn't need the laser etched marking on the rim of the gasket and weren't ready to pay for BPOG type extractables. So what we've done for silicone is added several gasket variations that'll meet the current industry expectations and what they're buying now, and it will also address future needs of the market for what they'll need for validation and testing of product-wedded component parts going forward. So the 5000 series gaskets, this top box, okay, it still includes that comprehensive validation pack, right, with the BPOG extractables and more, but we've added an option for unmarked parts. And again, that was based on your feedback and the feedback of the customers. So as with the 2017 launch, these gaskets are double bagged and heat sealed, very similar to what you would expect for typical Biopure components, and even similar to what you'd expect for something like pump seal. So in addition to that, this lower box here, we've added what I'll call the RXPX series. These use the industry standard part codes, okay? They are still made in a clean room, but they only have basic biocompatibility testing like USP Class 6. So this aligns with the current market needs and what the market is currently buying. So this RXPX series is really right at par, or maybe it's even a little bit above par with what our competition has and what's on the market today. And that's both from a validation perspective and price, okay? So there's some additional points on the box on the right here. I'm not going to walk through each one one by one. Again, I suggest you visit the website, look at the cut sheet, and if you have any questions, please don't hesitate, call me and ask. So next, EPDM. Right? EPDM has widely been used in multi-use systems for many years. And why is that? Well, it's a cost-effective material, it provides an excellent seal, and it has good resistance to multiple SIP cycles. Okay? If you go back and reference the application chart, you'll see it has far better resistance to repeated SIP than something like silicone. Okay? And it's more, it certainly seals better than a solid PTFE gasket. It's not as pure as silicone, which is why you don't find EPDM in many single-use applications. So those factors, combined with that relative price, have really made EPDM the most commonly used choice for stainless steel or multi-use biopharm and pharmaceutical processes. Okay? That being said, not all EPDM is created equal. So this picture shows our product on the left against 3 competitors' product, all after 117 hours at 130 degree steam exposure. Okay? You can see that the Biopure compound on the left has proven to maintain its integrity even after exposure to steam for that amount of time. Inferior compounds, like some on the right, will begin to degrade and can actually start to extrude into the ID of the pipe and stick to fittings. And this can occur without any sign of leakage. So the customer really won't know there's a problem until they either disassemble the system or until it's too late, like potentially something like a piece of gasket has fallen off into their process. So we do have a brochure and technical information related to the testing that's shown here on this page. It is coming soon. If it's not available at the time of this release, please go back and look for it, but it is something that we've made available, we're going to make available, and something you can share with your customers. And it basically walks through some of the dangers of using an inferior EPDM compound and highlights the benefits of the Biopure EPDM gasket. So keep an eye out for that if it's not out already. So a little bit about PTFE, okay? PTFE gaskets are used in many applications. They are out there, and as you know, when we discussed, PTFE is one of the most inert and most pure compounds available. So it's often used in places where ultimate chemical resistance or high purity, ultra high purity is required. However, as a gasket, PTFE does not make a great seal, and it really requires more care and more attention to installation and more regular checks on the installation and clamping torque than a rubber-based gasket. So it's more prone to leakage, especially during wide temperature variations. So an envelope gasket, shown in this bottom picture, addresses that sealability somewhat by incorporating a rubber insert into a solid PTFE gasket. So you can see that right in the picture. It's basically a flat rubber gasket that's inserted into a slot made in a PTFE gasket. That's an envelope gasket. So still not quite as leak-proof as a pure rubber compound, but it does provide some additional security with regards to the seal over a solid PTFE gasket. And you will find customers who may be interested in that as a solution for one of their applications. So that brings us to polysteel, also a PTFE-based compound. Polysteel and compounds like polysteel were really specifically developed for heavy steam applications, continuous steam applications. Polysteel is a 50-50 blend of stainless steel and PTFE. Okay, the material seals a little better than solid PTFE. It doesn't cold flow like solid PTFE. It's really ideal for clean steam lines and where the gasket is under continuous steam pressure and continuous steam temperature. Okay, it's higher priced than PTFE and envelope gasket, but customers may be willing to pay for that in applications where they really have heavy steam usage, and you will find that out there in the market. So keep that in mind for polysteel. And finally, Viton. Viton is a rubber compound as well. It has superior chemical resistance compared to EPDM, and while it's not as commonly used as EPDM, this is an option for applications where harsh solvents or cleaning chemicals are being employed. So you would expect to find this more in small molecule or API applications. You won't typically see a Viton gasket in a pure biopharmaceutical process, okay, but they are out there. It is more expensive than EPDM and PTFE, but it provides better chemical resistance than EPDM and a better seal than PTFE. So while it's not that common, it does round out this portfolio nicely, and you will find customers who may have an interest in Viton. Okay, so that brings us to the end of the technical review. So please go back, visit the website, review the technical sheets, review this chart. Okay, you can watch the video presentation again, and of course, contact me with any questions. So again, if it's not already on the website, an EPDM brochure is coming specifically regarding steam resistance. Okay, we do have some additional testing coming in the coming months regarding to autoclave cycle testing, and as well as some additional SIP cycle testing. I do want to make a note, okay, and you should know this, there is an industry group called the ASME BPE. They do generate guidelines for biopharmaceutical processing, and specifically they have some guidelines around SIP testing for rubber seals. Okay? In the coming months, we will be generating that exact BPE type testing, and that will supplement the steam testing that we already have. Okay? When that's ready, I'll make you aware of it. There'll be a short training. Okay? It's pending right now, but I just wanted to let you know of that industry group and what's coming so you can be prepared if a customer asks. Okay? So that's it for the technical portion. All right, up next, we'll be talking commercial considerations. And again, contact me with any questions, and let's move on to the final piece of this training.